Okay, in the last videos we introduced sets. So now let's have some examples that we're gonna use a lot. So the first is just the natural numbers. Like you count on your fingers. 1, 2, 3, 4, one finger. You have 2 eyes, 2 ears, the number 2. Uh, and you just keep on adding 1 forever, and you'll generate the natural numbers. Starting at 1 does not include 0. If you put, and that goes on forever. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, then you make the whole numbers out of that where you include 0. So here you have the natural numbers are a subset of the whole numbers. The number 1 is in here, it's in there. And the number 10 is in there, it's in there. The only thing that makes this a proper subset is because 0 is a whole number, but it's not a natural number. Okay? Those are the ones we start with in elementary school, right? Then we move up to fractions, Q, quotients. That's of the form, I don't know, P over Q. Let me use A over B. A lot of times, if you talk about primes, it's P over Q. Where A and B are, oh, no. Ha, I'm skipping. Actually, the next one we need is ZZone, the integers. That's the whole numbers and their negatives. It's like plus or minus 1, plus or minus 2, on forever. So the whole numbers are a subset of this, and the natural numbers are a subset of this. Now you can take quotients of the integers to make the rational numbers. The rational numbers, that is of the form A over B, where A and B are integers, but B cannot be 0. That's the rational numbers. So these are decimals that either terminate or repeat. And therefore, the irrational numbers, I don't know, we'll say I, are decimals that do not repeat and do not end. So I'm not going to write that out. The irrationals are decimals that do not repeat and they go on forever without a pattern, like pi, for example. Or the square root of 2 is an example of an irrational number. Together, the irrationals and the rationals make the real numbers, R, which are just these all digits, through 9. Decimal, B1, B2, they can go forever. So it's just all decimals, all numbers with decimals are the real numbers. Basically, we often represent the real numbers by the number line. And it's everything on here. All the space, and there's a lot more irrationals than there is rational numbers. Now we can go further. So we have the natural numbers. Basically, when we take 0 with that's the whole numbers, When you make fractions with those, you get the rational numbers. When you take everything else but the fractions, the terminating decimals, you get the irrationals. When you put the rationals and the irrationals together, you get the real numbers. Now, you can get imaginary numbers if you allow squares to be negative. So we define I squared as -1. So in other words, I is the square root of -1. Then if you have like -5, square root of -5, that is the square root of 5i. So it allows you, imaginary numbers allow you to think about negative square roots. Then you define the complex numbers to be all numbers of the form a plus bi such that a and b are real and I squared is -1. And then you can represent the complex numbers with by coordinates a, b, where the x-axis are the real numbers, the y-axis are the numbers with the I, and that will be called the complex plane. So we have containments. There are also algebraic numbers, numbers that solve a polynomial. I guess you can use rational coefficients or integer. And then the ones that are not solutions of polynomials like that are transcendental. They transcend those polynomials. And for example, pi and e are examples of transcendental numbers, while x squared minus 1 is solvable by the square root of 2, so that's algebraic. So there are either, algebraic irrationals or they're transcendental. Okay, so you have the containments. Let's see, we had the natural numbers contained in the whole numbers. Those are contained in the integers. The integers are contained in the rational numbers. The rational numbers are contained in the real numbers. And the real numbers are a subset of the complex numbers. Oh, I ought to put in here that, so the irrational numbers, we'll call them I, is a subset of the real numbers. Let's see, I could show you stuff about these types of numbers. They're all sets. I just wanted to introduce them on my channel because we're going to use them. So you needed to know what they were. These are numbers 1, 2, 3, 4, 5 forever. Whole number, natural. Whole numbers are the natural with 0. That's 0, 1, 2, 3, 4, 5. The integers are the ones you count with, like on your fingers, and they're negatives and 0. The rational numbers are fractions made out of the integers. The irrationals are everything else on the real line. And those are decimals that do not repeat and do not terminate. The real numbers, like what's on the number line, are the irrationals and rationals together. Complex are expressed as a plus bi, where I is the square root of -1. That's a quick introduction to the different types of numbers. I'll go into more detail in other videos. Thank you.